and hope this thing doesn't come flying down. All right, Mr. Knoll bought a bicycle. I love Mr. Knoll. I miss him so much. 5 years ago, it cost $237. The bike is now worth $92. The equation V equals MT plus B models the value of the bike as a function of time in years. So, that equation may look different, but isn't it the same as y equals mx plus b? The letters are different, but that doesn't matter, right? So, lines are made up of ordered pairs. Ordered pairs are x comma y, but in our vocabulary, x or ordered pairs will be t comma v. Does that make sense to you? So let's read the question and see if there are some ordered pairs in there. Mr. Knoll bought a bicycle 5 years ago that cost $237. The bike is now worth $92. Could we write a couple of ordered pairs for that? When he walked into the store, he paid $237, right? So the value is $237. What are you gonna put in there for T? You've got some choices. What do you wanna put in there? Five? Because that means after 5 years, the value was $237. Is that right? I think we can use 5, Amanda, but I don't think we want positive 5. Wouldn't we need a negative 5 there if we were gonna do that? That's 5 years ago.
Or a zero. Can you do a zero?
You can put a 0 there. You can set this up different ways. This was the initial value of the bike, so it makes sense to me to make that times 0 the original value. And then this one would be 5.
Yep.
And that value is 92. Now, if you want to go 5 years ago, Amanda, and do negative 5, you can. That's kind of a weird concept to do negative 5 for time, but I mean, I understand what it means and it would work, okay? Now, how many years ago was the value of the bike? 150. Well, should we write the equation of this line? And then we can figure out when the value is 150? So here we go. What is the equation of this line going to be? Well, I'm going to do my slope. And I'm probably going to need a calculator to do that because these numbers don't look very pleasant. So 92 minus 237 is negative 145 over 5. Negative 29. My slope is negative. Does that make sense? Yeah, why, Nyla?
Because the,
What's happening to the value of the bike?
it's going down.
It's going down. It's called depreciation. So it makes sense that this is going to be negative. So I'll pick a point. How about this one? That's the y-intercept, isn't it? So my equation is V equals negative 29t plus 237. Now, if you use different points, you will get a different, maybe you'll get a different line. It won't matter to the final answer though. All right, so now the question says, when will the value of the bike, or when was the value of the bike 150? So what do we do? Plug 150 in for the value. Everybody understands why it's going in for the value, right? So we'll subtract. It says round, but I got 3. Did you get 3?
3 years, right?
3 years. Now, This, when I wrote this problem, I did not intend it to be tricky, but it really is a tricky problem. Let's just stop here. Nothing this tricky is gonna be on the test, I promise. Let's talk about why this is tricky. Would everybody agree P is 3?
Yeah.
So what that means in terms of the ordered pair is 3, 150. That would be the ordered pair. So at time 0, at the beginning, when you walked in the store, the bike was worth $237. Now, 5 years later, it's worth $92. Read the question. What makes it tricky? How many years ago? Okay, now wait a minute. This is now. This is when it was worth $150. So the actual answer to the problem is two years ago. But that's incredibly tricky. I'm not gonna give you anything tricky like that, but you see what I'm saying? How many years ago would be from now? And that was 2 years ago that it cost that much money. But you're gonna get a problem, you're gonna solve it, and whatever you get is gonna be the answer. You're not gonna have to do that trickiness. All right, that was a great choice. That's kind of a challenging problem. Let's do one more, and then we'll look at some old papers that I just returned. Who else found one on the review sheet that you have no idea what you would be doing? Braden? Number one?
Well, like, I know like what it is, but I don't know how to.
We don't know the properties?
Yeah.
Oh boy. Oh boy. Okay, here we go. Who knows any of those? A, B, C, D, or E? These are all property questions. Probably aren't gonna have this many on your test, but you will have some property questions on your test. Katie?
Is A additive inverse?
It is. Thank you, Katie. Additive inverse. The reason it's additive inverse, well, first of all, it's an addition problem. And second of all, what happens when you add a number and its opposite? They cancel. And whenever you cancel things, it's an inverse. That's what an inverse does. An inverse cancels. So if you are canceling, you are an inverse. In this case, it's addition, so it's additive inverse. Perfect. Good job. Okay. Anybody know another one? Nyla?
B is the commutative property of addition.
B?
Yeah.
Yeah, B is commutative. Because what changed, guys? The order. When you go from 2A to 3B to 3B plus 2A, we know that isn't going to impact our answer because addition is commutative. You can go in either order. Very, very good. Okay, so far we're on a roll. All right, anybody see another one you know? Katie?
Is E associative?
E is, actually it's not associative because what changed? Katie, when you have associative means you left everything the same, you just grouped differently. So this would be associative, where 3 and 4 are grouped here, but 2 and 3 are grouped here. What's happening in E is not a regrouping.
Yeah,
Commutative, yeah, that's a tricky question. Sometimes we see the parentheses and we think it's associative. Does everybody understand why E is commutative? The order changed. You rearranged. When you rearrange, it's commutative. Perfect. All right, who else? Nyla?
Is C the additive identity?
No. The additive identity would say A plus 0 equals A. The additive identity is adding 0. This is a property you used a ton in geometry, but we really don't use very much outside of geometry. It's the reflexive property of equality. When something equals itself, it's reflexive. That's the reflexive property. If you're adding 0, that's the identity. Or timesing by 1, that would be the identity. In Schoology, there's an identity, or an extra property practice, I forget what I called it, but there's a worksheet in there with the answers. I handed a few out to some of you requested a copy, I gave some of them out. I think I have some extras, I'm not sure what bin you're in back there, but it's in Schoology too. And then D, we always get confused with commutative. It is not commutative. It is symmetric. The reason it's not commutative is, commutative has to involve an add or times. This is a flip across the equals. So this is the property, symmetric is the property we use. Sometimes when we solve an equation, we get something like 7 equals x. That looks funny to me, so I turn it around and write x equals 7. That's symmetric. So again, that's not a huge part of your test, but there are questions on your test about properties. So if you need to go back and review, you can do that at the end of the period, or maybe at lunch. I'll see if I can find those extra sheets in case anybody wants one. All right, so let's pause on that. There's a bunch more questions, kids, we need to practice on. But let's go back to either the quiz that I just turned back or a homework that I turn back at any time and you're not sure about what you missed, why I marked it wrong. Yes?
I haven't taken the quiz
Doesn't matter.
yet. Okay.
You'll get a different one.
Okay.
And you have enough work, so you gotta get a bunch of work done.
Yeah, I'm gonna post it, okay?
And you get it in. Charlie, your hand up?
No.
Yep. This is my recording book. No one has a question about anything that I have given you back, either today or another day, it doesn't have to be today, that had a pink mark on it. No one has a question. Now we have one, Charlie.
Could you do number 4 on yesterday's quiz?
Okay, good. How many hearts did your quiz have?
1.
1 heart, number 4. So we have to simplify. I think everybody had an exponent problem on your quiz. So even if this wasn't your particular problem, pay attention, because it's solved the same way they're all done. Or I should say simplified. All right, I think I copied that right. All right, what did you do first, Charlie?
I multiply everything by the equation outside. That's
To the
where I went
third
wrong.
power?
Yeah, that's where I went
Okay,
wrong.
okay. That would, again, you can do this however you want. I think it's easier before you start doing that, because these are gonna be big numbers. 9 cubed is, we're not messing, that's a big number. Before we do that, let's clean up this inside. Make everything as small as we possibly can, and then we'll do the cubing. It'll work your way. It didn't, obviously, so let's try this, okay? So what simplifies in here? Well, 6 and 9 become 2 over 3, just regular reducing. How about my x's? What happens here? X3 on top, because you got 4 up there and 1 down here. Don't ever forget, kids, what that means is this. So when you cancel, you have the extra 3 on the top. Now, this one's a little trickier, because you gotta bring these down. Because of the negative exponent, these come down. So now I have y to the 8th. There's 5 already down there. I'm bringing these 3 down. That gives me a total of 8. Opposite here, these go up, giving me a z to the 6th. Now, I can cube it without too much difficulty. 2 cubed is 8. X cubed is x to the 9th. Remember, we multiply a double exponent. Z to the 18th. And then 27, y to the 24th. Okay? All right?
Yeah.
All right, Katie?
Can you do one on one of the homeworks?
Yep. Then tell me which homework it is.
P5. And the first one.
P5, find the center and radius of the circle. Well, in order to do that, it's super simple to find the center and the radius if the circle is in standard form. This one is not. So, let's go back and refresh our memories what standard form means. I rearranged my equation a little bit because I need to get it looking like this. That's the standard form of a circle. If I can make my equation look like this, I know the center of this one, this is a different equation, but the center of this one is 4, -1. And the radius is square root of that, okay? So I gotta get that mess looking like this. These are squared quantities, so I'm going to complete the square to make a square. So half of 10, so that's why I grouped my x's together and left them blank. So half of 10 is 5, squared is 25. Don't forget, it's got to go on the other side too. Half of 2 is 1, squared is 1, it's got to go on the other side, 2. So this is now a perfect square. It's going to look like this now, right? This is going to be x minus 5. And then plus, this one is going to be y plus 1. And that's 20. So now I can answer the question. The question was, what's the center? Well, the center is 5, -1. And the radius is the square root of that number, which is 2√5. All right, anybody else? Any paper that I handed back?
On homework P6, 2A.
Okay, that's a simplifying. So probably all we want to do there, we don't want to make this harder than it is. We want to distribute the -2 and then collect like terms. So -7 minus 6i. This is not a FOIL. Please don't FOIL that. It's not a FOIL, it's just a collect like terms problem.
4 on the last quiz.
How many hertz did you have?
Those parts, 2.
2. Number 4.
Uh-huh.
Write the equation of the line perpendicular to this equation and containing this point. All right, so you've got this equation, and you've got this point, and you want to write the equation of the line perpendicular. So what does that mean to an algebra student? Perpendicular means opposite, reciprocal, slope. So I need to find the slope. How do I find the slope of this guy? Subtract x. And I'm gonna be real careful when I do that, guys, because there's still a -4 there. Don't lose that negative, right? So y equals, I'm gonna divide everything by -4. 1/4 x minus 3/2. Don't get all hung up about the 3/2, it really isn't important. This is what you were looking for, right? So the slope of this line is 1/4, which means my perpendicular line will be -4/1. Then y minus 2 equals -4, x minus 3, there we go. Done.
I've seen switching.
Oh, so you did it like it was a parallel?
Yeah.
Yeah. simplify. Square root of negative 16 times the square root of negative 24. Now, this is such an easy thing to overlook. When you have the square root of a negative, that is the first thing that needs to be addressed. So I know you're kind of used to multiplying radicals, but you can't do that if you've got a negative. When you're taking the square root of a negative, step one is I root 16 times I root 24. That has got to be the first step. Now, you can do whatever you want with those radicals, but you had to pull the i's out first. So I've got I squared. Square root of 16 is 4. And square root of 24 breaks down somehow. 2 root 6. What's I squared? Negative 1. So it looks like I have negative 8 root 6. Negative 1 times 4 times 2, and then root 6.
Could you solve it by like, instead of, like just multiplying radicals, like multiplying 16 times 24?
You can, once you pull the i's out. Yep, you can do 16 times 24 and then break that down. Now, I think that's harder, but if that's what you wanna do, you can. It gives you a big number.
Yeah, I
But-
think I just like did the wrong math or something. I
Okay.
took the i's out.
Okay, then you probably just made an arithmetic mistake somewhere. Yeah. All right, let's do another one. Who else? Okay, is this about something you haven't turned in yet?
No.
Okay, it's a paper you got back?
Yep.
Okay,
Number 3 on P3.
2 to 3, number 3. Oh yeah, a lot of you got this one a little bit turned around, not bad at all, but a little bit turned around. The job is to solve for this. Okay, so you did it different ways and all of it was absolutely fine. One option is to distribute over there. You don't have to do it that way, but that would be one option. Okay, so far? And then, since I'm solving for that, I might subtract this over. So y minus y sub 1 minus mx sub 1. And this is where we ran into a bit of difficulty.
Can you use regular X on the left
Oh,
side?
thanks, yeah. Subtracted this one over. What do I have to divide by?
Are we solving for X1?
Negative.
Uh-huh,
Negative M.
uh-huh. So that's gonna give me this. Now, some of you tried to simplify that. You have to be really careful because if you wanna break it up, you can. So you're gonna have y over negative m plus y1 over m, because those negatives will cancel, plus x. So your answer could take many different forms, but it has to have the signs, S-I-G-N's, of these. You might have it all combined into one, you might have it split up into 1 and 2, I don't know how you split it up. Who asked me this question? Oh, have you figured out where you made a mistake?
Kinda.
Tell me what you wrote.
I wrote x sub 1 equals y minus y1 over negative m. That's it.
Oh, you lost your X.
I guess so, yeah. I don't.
Yeah, that part looks good, that part's right here, but you need to have an X on there.
I started by dividing out the m,
Mm-hmm.
so I don't know where it went
You
wrong
just-
with that.
You need to subtract that X over.
Yeah,
think I just wrote it wrong, honestly.
Okay, well anyhow, you got it, right?
Yeah.
All right, Charlie,
On that one, I got negative y plus y1 over negative m,
negative y plus y1,
over negative m plus x equals x1, is that right?
yeah, that should be right. So if I mark that wrong, it should be right.
Okay.
Oh, wait a second. Yeah. No, it's not, because it needs to be y minus y1 over negative m. If I, okay, so I'm gonna split this right here. So this is what you should have, you've got that backwards. You see how your signs are wrong, so I'm not sure how that happened. If you're gonna divide by a negative m, I don't know what happened. Somehow your signs came out wrong. I don't know. All right, let's hit the lunch. I want you back in the seats at 50, and I'll see if I can find some property sheets in the meantime. Yep. Here's my thing, Ally. I do not want to go down last year's path.
No, neither do